are the top 4 machine learning projects you can complete while learning machine learning. The first project is a medical insurance cost predictor, where we'll be using a bunch of information about a person, like their age, body mass index, how many children they have, whether or not they smoke, and more to predict the output, which is the insurance costs in dollars. Under the hood here, you'll use a method called linear regression, which is the easiest way to predict a number in machine learning. It starts with something we've all learned about, which is slope-intercept form, or y equals mx plus b. Essentially, the model plots this simple line through your dataset and keeps adjusting the values of m and b until the error in the model is as low as it can possibly be. And here we call the coefficient m the weight of the input x. When you have many inputs, the model just adds more terms to the equation, one term per input, each with its own weight. The training part is just the model adjusting these weights so that across thousands of real examples, the predictions land as close as possible to the real data. And in my opinion, linear regression is the best way to start coding machine learning projects because the math behind it is so intuitive. And a good Kaggle dataset for this exact project is called Medical Cost Personal Dataset. To code this model, you would first load in the CSV, then set the insurance to a label called Y, keep all the other columns in a feature matrix called X, convert the categorical features into numbers using one-hot encoding, then split into training and testing sets, finally fit the linear regression model, and finally run it on a real-world person, maybe even yourself. The second model will be a cancer tumor classifier, where we'll be using inputs such as the measurements and texture to predict whether the tumor is malignant or benign. For this kind of yes or no question, we'll be using a logistic regression model, and you can think of this as the probability version of linear regression. Essentially, instead of outputting a single number, it outputs a probability that the inputs can be classified as a certain class. It still starts by combining all the inputs with weights, just like we talked about before, but then combines them into a single number that sits between 0 and 1. So then it can say something like, there is a 0.82 chance that the tumor is malignant. After you actually have that probability number, you pick a cutoff, which is usually 0.5 by default, and anything above that cutoff is malignant, while anything below it is benign. A standard Kaggle dataset for this project is the Breast Cancer Wisconsin Diagnostic Dataset. And to code this model, you would load in the dataset, set the label to 0 for benign and 1 for malignant, split into training and testing sets while keeping the class balance similar, scale the features so they are on a comparable scale, then train the logistic regression model, and finally evaluate using a confusion matrix. Finally, you can input information about a real-life tumor to predict whether it's malignant or not. The third model will be a taxi tipping classifier, where we answer the question, will a rider leave a tip that is more than 10% of the fare? And we will use inputs like the fare amount, trip distance, pickup location, and more to predict the outcome, which is a yes or no label of whether the tip crosses the 10% cutoff. For this model, we'll be using a decision tree, which is easiest to picture as a flow chart that the computer designs for you. It starts with all the data and then asks one simple yes or no question that splits the data into two groups, like is the fare above this amount or is the pickup in the evening? And then it keeps asking more questions inside every group to keep splitting and keep splitting. And after all of the splitting, you end up with boxes at the bottom where almost all of the training examples in each box either did tip 10% or did not. The training process is basically the tree trying lots of possible questions and cutoffs and keeping the ones that split the data the best, so you don't have to invent any rules by yourself. To code this, you would load in the dataset, set the target as a yes or no label that marks whether the tip amount is greater than 10% of the fare amount, clean out all the obviously bad rows, create simple time features, classify your inputs, turn those categories into numbers using one-hot encoding, split into training and testing data, fit a decision tree with some max depth limits, and finally evaluate with a confusion matrix and precision and recall. And when it comes time to deploy, you input all of the features and the model walks them down that full flowchart until it ends up at a single classified box. And finally, the fourth model is a loan default classifier, where we will be using inputs such as the loan amount, interest rate, and percent income to classify the output, which is whether the customer defaulted on their loan. And for this model, we'll be using a random forest, which is a big group or ensemble of decision trees that all learn in slightly different ways. The reason this helps is that one single decision tree can latch onto weird patterns in the data and get overconfident, while a forest tends to be way more stable because no single tree gets to control the final decision. Each tree is only trained on a random bootstrap sample of the data, and at each split, it's only allowed to consider a random subset of the features, so each tree ends up diverse. And when you predict a new loan, each tree votes, and the forest averages these votes into a single probability of default. And a good dataset for this is the credit risk dataset on Kaggle. To code it, you would load the dataset, set the target label, clean out the missing columns, encode the categorical columns, split a train and test with stratification, fit a random forest, and then finally evaluate using ROC AUC plus precision and recall. When you deploy it, make sure you choose a probability cutoff that matches how cautious you want the model to be about catching a customer who might default on their loan. I've linked fully functioning example notebooks for all of these models in the caption, so don't forget to save this video for your next machine learning model and follow for more. See you in the next one.